Okay, today we actually, last time we finished the method and testing, right? Here, today we will be going to conditional and logic, okay? We're going to this conditional logic. So here, let me actually get started with the whiteboard. Before we talk about this, let's talk about Boolean logic, Boolean algebra. Okay, let's talk about this. Let me turn to Boolean value. We have Boolean value, Boolean variable, Boolean expression, Boolean function. Okay, different type of Boolean thing. And Boolean actually just means true or false. Or some people call it logic. Actually, it's called formal logic or mathematical logic. It's not really the philosophical logic we are talking about. It's not really the theological logic. Theological logic is more complicated. So let's first look at who is the guy who invented this guy called George Boole, a British mathematician. Okay, this guy called George Boole. Okay, there's a guy called George Boole, and he's a mathematician. And his main contribution is in this Boolean logic, Boolean algebra. Okay, and it's called Boolean algebra because it actually very apparently that's because his name, right? He put as a Boolean, so it's a Mr. Boole's. Actually, it's a Mr. Boole's logic. Okay, something like that. So he actually had a major contribution to this field. Okay, and Boolean actually is just 0 and 1. It's not really that hard. So something, it actually just had logic. It actually just had logic, and you actually had true or false. And true or false sometimes write as 1 and 0. Okay, and in Python, in Java, let me bring this up. In Java, it actually only has a true or false. Java's name is actually true or false. And in logic, you have TF or 1, 0. Okay, we'll explain this later. Now let's focus on the logic. The formal logic is like when we talk about something, say, it is raining. Okay, it rains, so the ground is wet, right? If we make such a statement, say it rains, so the ground is wet, right? And then this actually means what? If we formulate it, we have something called P and then Q. This is the way formal logic will write. Actually means if it rains, and then the ground actually is wet, then this one is okay, right? And if it rains, and then it is not wet, it's not wet, actually it is not following the logic, okay? And then if it doesn't rain, and whether it's wet or not wet, actually we don't care. So actually this one actually both are true. Actually both are true. Okay, this is the formal logic of if P and then Q. That's the logic, and usually if we have Q, we can write as not P or Q. Okay, we can write as not P or Q. That's the logic. So if it rains and the ground is wet, then it follow our logic because it rained and the ground is wet, right? And then if it doesn't rain, if it rains but the ground is not wet, then it is not following this. If it rains, then the ground should be wet. It actually not following it. So this one's false. And then if it doesn't rain, whether it's wet or not wet, the ground may be wet because somebody just spilled some water on the ground. So we don't know. We cannot judge whether it rained or not. So this one also follow the logic. So by this, actually, we have the formulation of P or Q, P to Q actually equivalent to not P or Q. Okay, and P and Q we can come up with P and Q. We can come up with something called this one. I'm sorry, zero. I'm sorry. Let me read this. 0, 1, 1, 0, 1, 1. This one is called truth table. The basic part when we do logic is we can come up with truth table. So not P actually, if we write this, it's called not P. Sometimes not P, we also write this as not P. Oh, this one is not P. Okay. So when P is 0, you got a 1 that actually is not P. The reverse of P. Okay. And then this one should be 0. And Q actually is this. Okay. So Q will be I'm sorry. Here we have not P or Q. You should get not P or Q. You actually get 1, 1, 0, 1, right? So actually, this one, as I mentioned, only when it rains, the ground is not wet, you got a false. Other than that, you all have true. That's the logic of not P or Q, and also it's actually if P then Q. The logic, formal logic. Is that okay so far? This one is a little bit abstract, okay, really abstract. But I just want to actually try to teach you how to formulate logic or some statement. So if I say if it rains and then the ground is wet, that actually implies that either it does rains and then the ground is wet, or it means that it doesn't rain and then whether the ground is wet or not wet, either way it should be fine, right? If I have money, then I'm well off, right? It means that if I'm rich, then I'm well off. But if I'm rich but I'm not well off, then it's not actually the logic. And then also, if I'm not rich, whether I'm well off or not, it doesn't matter, right? That's the logic. But it's a formula, something like for this formal logic. Or if I pass 90, I got an A, right? So if I got 90 and I got an A, that's fine. But if I pass 90 and then I did not get an A, that's not logical, right? And if I don't get 90, or it doesn't matter, it actually got an A or doesn't got an A, it doesn't violate the logic. Is that okay? So that's the formal logic, okay? So it's formal, so actually it's very abstract, okay? Now, before we go any further, let's look at what is in Java. In Java, we have this guy called not. And then we have this guy called end. And then we have vertical to bar, this guy called or. Okay, so when we have a variable, we call it Boolean. And then this Boolean can be, A can be true or false. Or false. Then A and B can have, if I have a 0, 0, 0, 1, 1, 0, 1, 1, A and B, here I should erase this. A and B means like when both of them are 1, it's 1. Other cases, 0. It's false. Okay, this is called end. Is that okay? A and B means that both of them are true, and then I'm true. Is that okay?
Yeah. Yeah.
Okay. And then next one is or. Next one is or. Let me erase this. So the end case is like, let me think about it. Okay. End case is if, okay, a full around student is like academic, perform well, and has good, is a good athlete. Say if the definition is that. Okay. So it only is true if you are both academically super and also you are athlete. Then you can claim yourself a all-around student. If you miss something, actually you are not. Is that okay?
Yeah.
That is probably a better example. Right here, let me talk about or. So again, I have the A and B, right? So if my actually, I write down as this. I say, say I got an A in this semester. Say I have a statement. Say I got an A in this semester, and A means I got an A in math, right? B means I got an A in English, right? So when I say I got an A in this semester, actually means one of the subject I got an A, or both of the subject I got an A, right? Only if both the subject I don't get an A, then actually this statement is false. Is that okay? So this one called and, this one called or. Two vertical bar, this means or. Okay? And the third one actually is called not. So if I have an A and I say it actually either 0 or 1, not A actually means 1 or 0. 1 and 0 is reverse of the A. Is that okay? So now let's go back to our slices. So that's the basic logic we actually will have. Okay, that's the basic logic we will have, and then let's start a program. Okay, let's start a program. So now let me actually new a project. So here, let me create a new project. Okay, right here is fine. So here I say it's chapter 5. Okay. Now in chapter 5, let me actually here say school. Okay, move this school. Okay, so simple Boolean logic is like I can have a Boolean A equal true. Okay. This is called a Boolean variable. This is called a Boolean variable, and I have Boolean of B equals false, something like that, right? And then here I can say, I can put, this one is called, these two are Boolean variable. Okay, and I can have like for, let me see. Okay, here. For int I equals 0, I less than, let me see, 2, okay, I plus plus, okay. And then I have for int j equals 0, j less than 2, j plus plus. Okay, and right here, if I equals 0, I'm sorry, I can have Boolean a equals so the first one actually that means Boolean variable. Okay, these two are Boolean variable. Now let me comment them out. Okay, and I can use write something like this. This is called conditional statement. Okay, so with this two actually, what happened is like with this two, I actually start my I equals 0, and then I less than j, right? So here actually, this one is called for loop. Okay, for for loop, my I initially equals 0, and then I go through the whole thing, and then when I finish, I go back and I increase, so I becomes 1. And you check this one, okay, it actually will pass, and then it continue to run. Okay, this is called for loop. So for loop actually has the concept of, okay, it has a concept of initially I set my I equals 0, and then it will check whether I actually less than 2 or not, right? After that, I will enter into the code body over here, right? And then at the end, I will actually update I increase, and then go back to check whether I is less than 2 or not. So every time actually I equals 0, and then the next time I equals 1, and then the next time I equals 2. And once I increase to 2, I actually will get out of the loop. Is that okay? So basically, this for loop will have I equals 1, run it one time, and then I equals 0, it run one time, and then it will have I equals 2, it run it one time. And then in the loop, I have j equals 0 one time, then j equals, j equals 0 one time, and j equals 1 one time. So basically, by doing this, I would have my I and j equals 0 and 1. I will go through this from here to here, and then from here to here, 4 different cases. Is that okay? And then if my I is 0, then I put my A to be true, to be false. And then my, if I over here, so A and B are false over here. A and B actually is like true and false here. And then here, false and true, and then truth and true. Is that okay? I try to create a truth table. So let's see, let me continue, okay? So here I say if I just system.out the print line, and then I have this A plus, and here I have an end plus B, right? I'm sorry, I should have, here I should have A and B plus equals here A and B. Okay. And I say where A equals plus B equals plus B. Okay, so let's run this. Okay, it will show you the truth table. Is that okay? So far?
Yeah, that's right.
How about Brendan? Are you okay with this? I try to construct the truth table.
Yeah.
Okay, so this guy actually I can copy, right? Actually can copy. I can copy this guy down over here. And then right here, actually I put or, right? Or over here, right? So this actually is called truth table. Is that okay? So the first one and only when both of them are true, it will be true. And then actually or it will be when one of them are true, it will be true. Okay. And this A and B we call it Boolean variable. A and B we call it Boolean variable. Okay, A and B we call it Boolean variable. So Boolean is just like a data type. You can declare it as a variable and you can assign value to it. Okay, and then you can do calculation, both and or. Okay, you can do the calculation. Is that okay? Now let me actually try the next one. Next one that's called leap year. Okay, let's call it leap year. So for leap year, we are trying to check whether a year is a leap year or not. Okay. So public static void. Okay, so we will have a year. Say, let's do this. Let's read in. Okay. Oh no, let's declare a year called INT year equal 1970. Okay. So we are trying to check whether this year is a leap year or not. Okay. So the first one I say multiple of 400, right? And then I say this one 19 actually year take modular by 400 equals 0. So this is called a Boolean expression. The right hand side is a Boolean expression. Okay, previous one when we talked about this, actually we assign value to it. A and B is called a Boolean variable. Okay, and right hand side actually is a I equals 0. This is a Boolean expression. A single value that hold a Boolean data is called Boolean variable. And I equals 0 is a Boolean expression. So when I equals 0, I assign false to A. When I equals 1 or anything else, I assign truth to A. This one called conditional statement. Conditional statement. Conditional statement means you have a Boolean value, and then the first part will return to the one to become the value to be returned. If this one is true, if it is false, this one true case. For case, it will return the later part. That's called conditional statement. Okay, and then right here for the leap year, first one I define if year divided by 400. The remainder is 0, and I say this is a multiple of 400, right? So the same thing I actually can copy and pass. So I create 3 different Boolean variables, and the right hand side of them are Boolean expressions. So I can actually do this, right? And I can also have another one. and this one table 0 by 4, right? So I have these three value, and the year is actually is a leap year. So when what? When the year is a multiple of 400, or what? It is a multiple of 4 and it is not a multiple of 100. One moment, okay. From school, my son's high school. Sorry. Anyway, so this one actually will calculate whether it's a leap year or not. Is that okay so far?
Yeah.
Okay, so then let's try something wrong with my multiple.
Wait, why did you have to do 400 and 100 and then 4? Why didn't you just do 4?
What?
You had to do like year, percentage 400, year percentage 100, year percentage 4. Why didn't you just do year percentage 4?
A year is a leap year if it is a multiple of 4, right?
Yeah, but why did you have to do like the 400 and the 100?
If it is a multiple of 100 and it is not multiple of 400, it's not a leap year.
Wait, I mean, like, why didn't you just do 4?
What?
Why didn't you just do variable 4?
First, let's talk about what's a leap year, okay?
Yeah, it's like every 4 years, but like, I don't know why you did the...
If it is a multiple of 100 but not a multiple of 400, it's not a leap year. 1900 is not a leap year.
But then why would it... Oh wait, so...
1900 is not leap year. 1900 is a multiple of 4, but it's not a leap year. So you have to search for the definition of leap year first.
Wait. Oh wait. I got it. Yeah, I got it.
So 2000 is a leap year. 1900 is not. 2100 is not. 1600, yes. Is that okay?
Wait.
Every 4 years there's a leap year. Every 4 years is the leap year, but the non-multiple 400 100 years, actually they are not leap year.
Oh, that makes sense.
Okay? So you do need to have that three statement. You do need to have these three statements. Is that okay so far?
Yeah.
So this one actually is called a Boolean expression. This one is called a Boolean expression. So here. Okay, so 1970 is a leap year is false. Okay, now the next one, let me give you a leap year too. Okay. Okay, leap year 2. Now we have this one only check for 1 year, right? And we use a 3 expression. So now let me go here. And here actually public static void name. Okay, and here I do system.out.print. Okay, now I do this for INTI equals 1800, right? I less than like 2020, 2021, and I plus plus, right? And now let's check system out. Oh, let me do this. Don't call it IHB. It's for index. So let me call it year. So my year actually increase every time, and then I say print line, and right here I say year plus year plus is leap year. Okay, plus. Okay, here I say like is leap year of year. So now I define a Boolean function right here. So I have like public static Boolean. When I do Boolean, it will return Boolean value. Okay, yeah. And here I need to put the name is leap year. And then here int year. Okay, I get the input of year and I return what? I copy this guy over. Actually copy this 3 over to here. I pass here. And then actually I don't need this. I delete this. Okay, right here. I have 3 statements. First one, I have multiple of 400, multiple of 400, or multiple of 100, but I do inverse of it and then the multiple of 4. Okay, I actually try to return this. Okay, so if it is a multiple of 400, then it's a leap year, no problem. Otherwise, if it is a multiple of 4, but not multiple of 100, then that is a leap year. So this one actually I can just return such a long Boolean expression. Okay, and when we do operations, say we have A and B, or I'm sorry, or C, it will do and first and then or. Or is lower priority, and is higher priority. It's just like A times B plus C. A and B will go first, and then C will be performed later. And in fact, Boolean logics, if you have Boolean logic, you have A and B or C. You can also write as A and B plus C. If you do Boolean algebra, you can actually convert it and write it that way as well. Okay, if you do Boolean algebra, you can also write in that way. Okay, right here, actually I define a function called is leap year. I check every year and I get the input of the year in, right? And I check if it is multiple of 400 or if it is a multiple of 4 and not multiple of 100, then that is a leap year. So let's do this. Then I compile and run. Okay, so basically this program will start from 1800 is not leap year, right? Every 4 years is a leap year, whatever. And then down to 1900. So here's 97, 98, 99. 1000, 1900 is not, right? 1901, 02, 04, all 4 years. So there is a total 8 year, just have one leap year around this, okay? And then 2000, again, 2000 is a leap year, okay? So this program will help you to calculate the leap year calculation. Okay, so this one I give you the idea. This one actually is a Boolean function. So in this three function, we have the Boolean variable a, b, okay, defined. Second one, we had a Boolean expression assigned to a Boolean variable, three Boolean variable, trying to construct it. The third one, actually, I have a Boolean function. So these are the different level of Boolean things. It all can be put into everywhere you check Boolean. Is that okay? Is that okay? Now let's do, let's go, this one called Boolean leap year 3. Let's go leap year 3, okay? And this leap year 3, actually, I have the same, I have a public function. Public static, static void main. Okay, and then I copy whatever in 2 in the main function over here and put it over here, right? And here, actually, I don't have that leap year function, right? So here, actually, what I'll do is like right here, I'll say if okay, let me remove this. And here I type else, okay. Okay, that's where I talk about a static function, right? I can actually declare static function in other class, right? And then I use my way of calling the static function, the static function, class function from the other class. This is the way I do it, okay? I show you how to call a static function from the other class function from the other class. That function is a utility function. Since I write a utility function to help to check whether a year is a leap year or not, I should always try to use it as much as possible. So here, actually, I put that class function over here, and that actually will help me to check whether a year is a leap year or not. And I put if, and then that logic, if it is true, then I print out, okay, that year I'm happy. Okay. Else, I print out, oh, that year actually I'm not happy. Okay. So now let me cut down to 1900. Don't want to print that many year. No, sorry, that starting from 1950. Okay. Since we know the function, it will work. So here, actually, you will see that work, right? So this one actually is an if statement and if else statement. If else statement is like I'll check is leap year, right? If true, then I say I'm happy. If it is false, then I say I'm not happy. Okay? So that's the if statement, if else statement. Is that okay for this if statement?
Yeah.
Okay, and then actually right here you can do this. You can also put if you have more than one statement, you can put a curly brace block that is called a code block. You can also do this. Okay, if you want to have multiple statement. So here actually I can put multiple statement. Something like that, and then I may drop down to 1990. Okay, even shorter. Okay, so you can actually have one statement that you don't need the curly brace, but you have multiple of them, you need to put some curly brace in there. Is that okay? Yes or no? Is that okay?
Yeah.
Yeah.
Okay, now then this one let's call let's call a function called a class called even. Okay, let's try another one called even. So now I'm going to try to check whether a number is even or not. So I receive a number, right? I will get the number from someone else. So it's x, right? And then I'll say if x take modular by 2 equals 0, right? And I will say this one I will do return true and then return false. Okay, and here for INTI equals 0, I less than 10, I increase. Okay, what's the difference between this one and the previous leap year 3? The leap year 3 actually is you had an if and then whatever, right? But this one actually it just had the if return true else return false. Okay, it is different. It is actually different, but functional wise, it actually pretty close. This one is called default false. So I can write actually this one. I can write if x modular equals 2 equals 0, right? And then I actually then return true, right? I can also say else return false, right? So I can have two case, but in fact, if it is true, if in fact it actually take it. I'm sorry. Okay. In fact, if it is true, actually it will just get the value and out. Right? It will get the value and out, right? And otherwise, you will actually get false. So actually, these two are equivalent. Is that okay? This is called default false case. This is called default false case. So let me write this. Okay, let me try this. This is even, right? Let me copy. Okay, you can also write this. You can also write this. Let me call this one is even 1. Okay, you can also so this one even 1, and here you can have boolean b equal false, right? And here you can say that b equals true, right? And here you can say else b equals false, right? And then return b. Okay, this is one way to do it. Okay, and then you can also copy this, and here you can do is even 2, right? And here instead of having this else, actually this can be removed, right? And let me copy this down. Okay, let me copy this down, and then pass here. Okay, and let me don't call it even. Let me call it even 3. Okay, let me call this guy even 3. Okay, and you can further reduce to this. Right, let me call it even 3. So here, let me call this one even 1. Copy, pass. Okay, and here let me hide something in there. Secret call even 1, even 2, even 3, even 4. Now I have another version called even 4 coming. Okay. This guy should be even 4. Okay, so why right here? True, 4, 4. So 4 false, 4 true, 4 false, 4 true, 4 false. So all of the 4 functions are equivalent. Oh, I'm sorry. Actually, I can just get one. I make a mistake. I should call all of them. Anyway. Okay, still 4 then. So the first one is actually full-blown version. You check whether it's true and then assign the value to it and then you return it. That's the full-blown version. Second one is a default false case. Your B set to false by default, right? And third one, well, I don't want to return that variable. I eliminate a variable and I actually just return true or false there. The fourth one, I just return the Boolean expression data over there. Is that okay? Is that okay for these? These 4 are actually equivalent. These 4 functions are equivalent. Okay, and then if I copy all these four, if I copy all these four, right, and pass here, and then right here, right here, I teach you how to modify program. You can hit Control F, type Control F, and you type even, right? And then right here, you click reverse, and then I check change it with odd. Okay, so it will start to check replace the run. So I say once, once, once. Once, okay, then forget it. I don't want to replace anymore. Now actually I copy this guy, right, and paste right here, right, and right here again from here I actually repress, okay, even repress is odd, okay, so actually let me see, I started from here, right, so let me see, I mean repress and then repress, okay, then once, okay, no, you actually couldn't see it, okay, so let me do it again, okay, let me just get out of here, okay, from here I actually Control F, okay, and then I have this one even, okay, and I replace with ODD, okay, once, 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 once. Okay, this even don't change, okay. Now I get all the value done, right? But here the logic is for even. So here I need to change this guy not equal, this guy not equal, this guy not equal, this guy not equal, okay? And I try this even class, run it. Okay, so true, 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 false, 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 true, 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 okay? So this quickly give you even and odd different combination, but you need to know these four different cases, actually they are the same. They are the same function or generality. Any questions so far? So we basically go through some if statement, checking for the whatever logic operator. Now let's go through this chapter's reading, okay? So relational operator, you have double equal sign means checking for equal value, okay? Single equal sign is assignment, so two are different, okay? If you have a band with equal, that actually is not equal to, and greater than, less than, greater equal, less than equal, okay? But remember, there is no something like this. There's no this, no, there's no not equal, there's no this, there's no this. It's not math. Equal use this guy, not equal is this guy. Greater, less, greater equal to, less than equal to, okay? So that's the basic operators. And if statement, I explained it already. Here you can put the Boolean value, Boolean expression, and Boolean function. So this guy you can put either is even or R, okay? And then if this one actually is equivalent to this, because this one only can attach one statement. If you want to have multiple statements in there, you actually need to have a curly brace to put it in there, okay? And then this one actually, these are fine, Okay, the next one is nesting. You can do nesting to get something. Hello? Any
Yeah.
question?
No.
Okay, now I'm going to do nesting. Okay. Okay, now I'm going to nesting. So here I say zodiac. Okay. Zodiac, Chinese zodiac. Okay, now right here, I should put public static void name. Okay, now I need to have some fundamental data. Let me see. I just need a string. Can there be something simpler? All of these are too complicated. I just need this thing. Wait, everything is so complicated. Okay. Then I just grab the first one. Okay, I'm sorry. I just grab the first one. I need a name, put it here. Okay. Okay, yeah. The year 2000 is dragon year, right? The year 2000 is dragon year. So here, let me see, here's right. The year 2000 is actually dragon year. So what if I have a year, okay, something like this, okay. Okay, and then I keep copying. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then here I put in 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And then here is like tiger, rabbit, dragon, snake, horse, goat, monkey, rooster, dog, pig. Okay. So these are the because I know the year 2000 is actually a dragon. So if I have 2000 minus 4 plus 4, actually I'll end up with 4. That will give me a dragon. So it is, I know 1970. Let me try this one. Like this year is like 2018, right? So here I should say system.out the print, then here say versus system.out the print line. Again, I use the word year plus year plus is plus zodiac plus year. Okay, so this one actually will detect what year this year is. Okay, so zodiac, let's run it. This year is track year. Dog year. Are we in dog year or no? Oh yeah, look like we are in dog year, right? Let me check. Actually, I'm I'm not in sync. I actually forget about what year this is. Yeah, this year is actually dog year, so that actually fine. Okay, now that's what we have here, right? So what we can do is like again, let me do this. Public static get year, right? And then I have to put a integer year, right? And then I copy the whole thing over here. Copy the whole thing over here, right? Okay, right here, not only teaching you the basic what is logic, and also teach you how to modify the program, okay? I also teach you how to modify the program quickly, okay? So here return this one. So all these are gone. I no longer need them, right? And here actually I should have the get year of year, right? And here I should have the for int I equals 1900, I less than 2021, I plus plus, right? Look nice, right? And then compile. Wait, something wrong? Oh, I forget the string. Something wrong. Year. Oh, sorry. I put the I in there. Oh, that's fine. No, that's wrong. Wait. Oh. How comes actually? Wait. There's something wrong. Let me see what's wrong. How comes it's only 0 will be passed? Year minus 2000. Wait, year minus 2000.
Wait, maybe it just shows the years that of rat because you don't like repeat.
Let me see. I don't repeat. No.
Well, I mean, like it just repeats rat, and rat's the first one.
Yeah, but the year
So,
this different year they get an empty string. So here, let me see. So actually, these are not executed. Okay, for some reason, this base file actually is not needed. Okay, let me see. Okay, and then when it is like equal 0, I get a really okay. It's a string. Let me actually check here. Okay, something wrong, but don't worry. Yeah, it's in there. It's in there, right? And how comes something just break before 1990? Something just break before 1990. Oh, you can have a negative number, so not maybe because it had a negative number or something. Okay, so if to solve this problem, let me actually think about it. 2000 probably got too big of a number. So let me see, okay? So here I have 2000, right? So 2000 divided by 12, I end up is 12, right? 80, 5, right? And 12, 5, I'm sorry, this one actually is like 6. I have 72 and 8 something, and then 6, I have 72. So I remember 8, okay? So here, instead of using 2000, let me use the one actually is, let me put this one, replace 2000. That's because of the modulus, okay? And then I replace that with 8. See what will happen, okay? And that will make sure that the year actually is a positive number. Year minus something will be a positive number. Let me see. That worked, right? That worked, right? You know what I'm doing?
Yeah.
Okay, so that's a way to solve problem. But if you actually have something like BC, right? You can actually just put a very big negative number, so you actually will be able to still handle it. Okay. So that's the problem. When you face problem, don't panic. Okay, you just see what can be the root cause of the problem, and then you try to solve it. Okay, so this actually give you the Chinese rotate, and then this one is the so-called nested what we see here, the chain and nesting if else. Okay, and logic operator we talk about this, and then if you have nested if and else, make sure that okay you understand this two if actually is similar to this, and then if you have a if else if, this else belong to the one closest to it. Okay, so this one actually something that, and the next one important is this De Morgan rule. Okay, De Morgan rule actually let me explain this De Morgan rule. This one actually is more important. De Morgan rule actually means, I try to prove De Morgan rule. Okay, so De Morgan rule actually means A or B, not A and B equals A bar or B. This actually, when you have the multiply, it actually means and. Have a plus, it actually means or. Okay, so this one actually is not A and B. It will be equivalent to not A or not B. Okay, I'm trying to prove this here. So the way to prove it is, okay, this is called De Morgan rule. So De Morgan rule actually says if you have A and B, right, and then here you have 0, 0, 1, 0, I'm sorry, 0, 1, 1, 0, 1, 1. So A and B will be 0, 0, 0, 1, and then A and B's bar will be 1, 1, 1, 0, okay? And then A bar is 1, 1, 0, 0. B bar is 1, 0, 1, 0. And then A bar or B bar is 1, 1, 1, 0. So effectively, this one is the same as this one. So basically, you have a bar outside. You in the inside, your n will change to or. Okay. Is that okay? This is called De Morgan rule for end, for named. Is that okay here?
Yeah.
This is called De Morgan rule. But to remember, it's just like I have A and B, and I have an outside bar. I just put, it's just distribute a bar for each one and then change the sign in there. So let's see another one. Let's see another one. Okay, let me erase this, erase all this, erase this guy. Let me actually erase this guy. Okay, and then this is the same. Let me actually erase this guy, this guy, this guy, this guy. Okay, and then here erase this guy, erase this guy. Okay, now actually let me put in AOB's bar will be equal to here. You know why I just erased those operators?
No.
Because it is two actually equivalent. A or B's are bar, and then so basically you have A or B, and not A or B. Actually, when you distribute the bar, you just change the sign. So here actually it's like you have a dot here. Here will be this. Is that okay? This is called De Morgan rule, and right here you have a dot. You have a dot here. You have a plus sign here. And here should be actually let me see. AWSB 0, 0, 0, 1. And here is like 1, 0. I'm sorry. Let me see. It's actually 1, 1, 1, 0. This one's 1, 1, 1, 0. Okay. Is that okay? That's called De Morgan rule. So basically, remember that De Morgan's rule De Morgan law just like you have the A and B bar, it will be A bar or B bar, or you have A or B bar, that would be A bar and the B bar. Is that okay? Change the sign when you take the bar to actually you take bar out. Okay, you take bar out. That's called the Morgan rule, and it's quite useful. Okay, it's quite actually that rule is quite useful. So like A and B bar actually the same as A bar or B bar, and A or B bar is the same as A bar and the B bar. Okay, so here the example, if x less than 5 and y equals 3 bar means that either x is greater or equal to 5 or y is not equal to 3, right? And then x greater or equal to 1 or y not equal to 7, it means x less than 1 and y equals 7. Okay, this is called De Morgan's law, De Morgan's rule. Okay, and then you have the Boolean variable. I talk about it. Boolean method. I talk about it. We have shown this Boolean just different function. You can look at this, and then validating input. This one actually just when you have the input, you need to verify whether the input is right or not. For example, the log, you need to check whether log is actually greater than 0 or not, right? If you have a domain problem, your log function is working like this, right? Your x need to be greater than 0 if you have a log x. So when you have a log x, when you input something, you have to check whether x is equal to greater equal to 0 or not. And also, if you have a divided by b, you need to check whether b is not equal 0 or not. If it is equal 0, you cannot run it. The program will have division by 0 problem. Okay, that is the validation for that. And then it has a logarithm checking problem. So let's run it. 87C. Okay, it's calculate the log for you. But let's run again. So if I just don't like it, I put a -2 in there. Okay, then the log is undefined. That's why this program work. Okay. So any question for today?
No.
How about Brendan? Are you okay?
Yeah.
Okay, so today let me make a summary. Basically, I start to talk about the Boolean variables, Boolean value truth table, and then trying to use that truth table to prove something, right? And later we actually go into these different series of function. Actually, right here. Let me sorry. I go into a series of functions, classes. So we get started from bool. I give you the Boolean basic Boolean value and construct a truth table using the for loop. And then deep year by expression, deep year by function, deep year by getting call from a class method, right? And then checking even by full-blown version of the logic, by default false, by return, by a single expression, right? And then we go into the Zodiac to do the nesting nested if. Okay, let me teach you one more, okay, before we break. I just remember something. So here, let's call this guy as zodiac 2. Okay, let's copy a zodiac 2. I almost forget this one. Okay, so what I will do with the zodiac 2 is like I'll copy the whole thing over. It's the same series, so let me copy the whole thing over. Okay, then class name I don't want to change. It's zodiac 2, so copy the whole thing here, right? And this one actually look a little bit busy, so I can actually do this. Let me call a variable called shift. Okay, and this shift actually I just copy this in. Okay, a something called shift is like this. Okay, and don't ask me why I call it shift. Okay, and the next one is let me do this. Else if this guy copy. Okay, and I do Control F. And right here, oh, it has that already. So here I do replace, and I do switch. I'm sorry, case. Okay, I just want to do case, and then do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. I still miss something. Okay. Here I am lazy. I don't want to do that. Let me actually try it one more time. This guy equal replace by equal replace by empty things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then here I do this right parenthesis. Again, I replace by column. Okay. 1, 2, 3, 4, 5, 6, 7, 8, whatever. Okay, here I need to change this guy as well. Right here, and then I do switch this guy here, and at the end I put this, right? This is so-called a switch statement. Okay, at the end right here, type break. Now this actually is a more advanced topic. Usually I teach in AP, but I don't know. Since we are here, I just make sure also teach you this to you guys. Okay. Compile logic 2. Yeah. Do the same, right? Okay. So this one's called switch statement. You put a variable there, and the value is 0. You go here to go here. But remember, you need to put a break after it. Okay. And when you can not to put a break, actually that's more advanced. We'll talk about it in AP course. Okay. Other than that, actually this will do the same thing. You check the shift value, and then you will check which one is it is, and then you get the value. Okay, so this one actually can be -4. Okay, so that's the last program to talk about. Is that okay so far?
Yeah.
This is a switch statement, but you need to study the switch statement yourself. Okay. I give you a good example, but you try to understand it. Okay. Okay, bye now.
Okay, bye bye. Thank you.
Bye.